The key denominator between selection control structures and repetitions is decisions. To code decisions in Python, you need to write conditions or conditional expressions. In this video, we will see how to write and evaluate conditions in Python. In Python, a condition is an expression that evaluates to either true or false. And these are the values of the Boolean data type. And in this sequence of expressions in here, the condition that we have is A greater than B. And think of a condition as a question that you ask to Python. And here we're asking Python the question, is A greater than B? So given that the value of A is 10 and the value of B is 20, the answer of this question will be false because 10 is not greater than 20. Now you can store the result of a condition in a variable, so we store this in the variable C. And if we print the value of C, you should see as a result false. And the type of this variable will be bool. The greater than operator belongs to a class of operators known as comparison operators. And these operators compare between values to either side of them and decide on a relationship between these values. You should be familiar with these operators from your basic math courses. The only thing I would like to note is this equal operator that is represented in Python by double equals. Remember that a single equal in Python means the assignment operator. And the assignment operator is used to assign values to variables, whereas this double equal is used to test whether the values of two operands are equal. To understand how conditions work, let's take a look at two simple examples. So here we have three variables. The value of A is 5, the value of B is 3, and the value of C is 5.3. And we need to evaluate two conditions. So the first condition is A plus B greater than C. Now remember, a result of a condition can be either true or false. So what is the result of this condition? So the first thing you need to do when you are evaluating conditions is to apply math operators because math operators have higher precedence than comparison operators. So in this case, A plus B is equivalent to 8. And the value of C is 5.3, and the condition boils down to whether 8 is greater than 5.3, and in this case it is greater than, so the result of this is true. Similarly, you will apply the math operator in the second condition, and B plus 2 comes 5, and the value of A is also 5, so the result of this is also true. With comparison operators, you can build simple conditions that involve two operands. If you want to build more complex conditions, you will need to use Python's Boolean operators. Python has three Boolean operators, and these are Boolean AND, Boolean OR, and Boolean NOT. The Boolean AND and the Boolean OR operators take on two operands, both of which has to be conditions or Boolean values. The Boolean AND is true if both operands are true. On the other hand, the Boolean OR is false if both operands are false. Unlike the Boolean AND and the Boolean OR, the NOT operator only takes on a single operand, and it returns the complement of the current Boolean value. That is, if the value is true, then the NOT operator will modify it to false, and vice versa. Now we have seen some additional operators. Here is once again the updated precedence table. One thing you should notice about this precedence table is that comparison operators have higher precedence to the other Boolean operators. Another thing that you should notice in here is that all your comparison operators have the same precedence. So if you have an expression with more than one comparison operators, these comparison operators will be evaluated from the left to right. So the ones in the left hand side will be evaluated before the right hand side because they all have equal precedence. Another thing that with the Boolean operators, the NOT have higher precedence than and if you have and or appearing in the same expression, and assuming that you don't have any parentheses to group operators or to group parts of the expression, then the AND will be evaluated before the OR. To understand how evaluation happens, let's see two concrete examples. So assume that A is equal to 12, B is equal to 18, and C equal to 21. And here we have two conditions, and these conditions now contain both comparison operators and Boolean operators. So first you have to evaluate the sub-expressions or the simple expressions first. So A is 12, B is 18. So is A less than B? So this is true. And then you have A is 12, C is 21. Is 12 less than 21? This is also true. And we know that true and true is also true. So the result of the first condition is true. Let's take a look at the second condition. So we know that A is less than C. So we've already done this up here. So A less than C is true. What about C less than B? So C is 21. B is 18. So is 21 less than B? So 21 is greater than B. So this is false. Now, I don't need to look at the result of B is equal to C because the result here doesn't matter. Python has something called short circuit evaluation. So that's the first thing. And we know that AND will be executed before the OR. So AND has higher precedence, and false and anything else is false. So this is false. So the result of this part of the condition is false. But A and C is true. True or anything is also true. So the result of this entire thing is true. Actually, having evaluated this expression now, you can actually Python does not look in reality. Python will not evaluate the second part of the expression because, again, as I said, Python applies something called short circuit evaluation. And because you are having the OR in here, and because the first part is true, so once Python evaluates the first part, the other part will have, or the result of the other part will be inconsequential to the result of the condition. So that's how you can evaluate conditions that have both Boolean operators as well as comparison operators.